In July 2020, David Sinclair was interviewed by Sam Bakhtiar, who is a doctor, an author, and was once a world-class bodybuilder. Sam asked David this simple question: do we age? Can we stop or reverse aging? And if so, have we done it in humans? David Sinclair talks about the diseases of aging and briefly explains his new concept or theory on why we age and how we can slow it down.
So what I put forth in the book is a brand new concept and some evidence to back it up. Now, clearly, a lot of things go wrong in our bodies. Heart, head, livers, all these do get older, and they break down in different ways, and we call these different diseases, cancer, heart disease, Alzheimer's. But the question is, do they all have an underlying cause? And I believe they do. And I put forward the idea that our bodies are losing information as we get older. And what do I mean by that information? Well, we know about the genetic information in the DNA, but there's another type of information that's just as important for life and health, and that's called the epigenetic information, and that controls which genes in our DNA switched on and off. And you can think of it as the DNA is the computer, and the epigenome is the software. And over time, it gets corrupted, and computers from the 1990s don't work so well, and the software slows down. But you can reboot the system and get it to work again. And that's what we've discovered. And I talk about it in the book, that we've got ways to turn back the clock and get that epigenomic information in the same way that we can reboot a computer and get everything working nicely again. 10 years ago, if I'd said we can reverse aging, people would have said that's impossible and thrown me out of the lecture theater. But now it's okay. Now that we've shown, and of course, some of my colleagues have done this too, it's not just me. We've shown that, first of all, there's a clock in our bodies that you can read. I could take your blood today and go back to my lab and measure little chemical changes called methyls on the DNA. And I could say, well, you're actually 36. You look really young, actually. So you probably are younger than most people your own age. Or you might be older, heaven forbid. But half the people will be above, half will be below. And what that's telling us is that you're losing information. Now, some of us in the lab have figured out ways to scrub those chemicals off, like you would brush your teeth and get the plaque off. And then the DNA gets read like it was young again. And now cells work like they used to. And we have a paper, a scientific publication that you can find online. We've posted it. The website is called BioRxiv, BIORXIV. And we hope that it'll come out in a prestigious journal in the next few months. Anyway, what we did was we took mice. Mice are easier to work with than humans, of course. So we took old mice, and they went blind because they were old. Or we could induce in their eyes the disease glaucoma, which you'll know is pressure in the eye that disrupts the retina. And in both those cases, we could rejuvenate the eyeball and get the retina at the back of the eye to work again. And those old mice could see again like they were young. And we measured the age of the eye, the nerves at the eye, and they literally were younger based on this clock that I was describing to you. So what does that mean? It means for the first time, we can apparently safely reboot the system and get very complex tissues and organs to work again like they did when we were teenagers. So it'll be probably another 2 years before that technology that we used, which is a gene therapy. It requires an injection in the eye. That'll be in humans in 2 years if all goes well. So we've raised the money, the capital to do that. But there's a lot of safety studies before you go into a person with a gene therapy. Although I will tell you that we're not using anything totally new. There are not vaccines, but gene therapies in the eye already to correct genetic defects. So it's not as science fiction as you might think. Has it been done in people? Well, there's been one study where people were treated with a cocktail of metformin, the diabetes drug, and growth hormone, and what was the third? Oh, DAA, which some of our listeners here today may recognize as a hormone that goes down with age. So I would say it's early days. It's like the Wright brothers, and maybe they've skipped over a sand dune. But show me you can fly for an hour and I'll believe you. That's where we're at.